It's vast. All of us know it. Named after the Roman god of war, the planet makes headlines every now and then for a number of reasons, mainly because it is the most Earth-like planet in our solar system, hence our desire to colonize it. However, if we seriously want to consider living in it permanently, we have to terraform it, and there are various ways we could effectively achieve this, but it would be very hard, and it would take a tremendous effort. Elon Musk even suggested dropping thermonuclear weapons over the poles of Mars just to speed up the process. Of course the capitalists want to nuke the red planet.
Firstly, what exactly do we mean when we say we want to terraform Mars, or any other planet in general? What do we mean when we say, let's terraform Mars, let's terraform the moon? What do we mean when we say something like that? Basically, planetary engineering, or terraforming, is the process of transforming a planet so it can support human life and be suitable for humans. Now you may be asking, why would we want to terraform Mars? Why would we ever consider moving to another planet? Well, thanks to pollution, climate change, future population growth, an increasingly higher demand for resources, and even an impending asteroid impact, and even poverty, many people believe that we should have a backup or another planet that we can comfortably live in just to ensure that humans and human race are safe. It may sound ridiculous, but by terraforming Mars, we can achieve wonders, not only by providing humans with 2 planets to live in, but it will also be a game changer for science. Now, we choose Mars over other planets because in many aspects, Mars is the most Earth-like of all the other planets of our solar system. Mars also had a more Earth-like environment early in its history with a thicker atmosphere and a lot more water, which was lost over the course of hundreds of millions of years. However, now the planet has drastically changed, but you may be asking why. Why did Mars die? In a way, it did die. Well, during the Noxian period, Mars encountered a high frequency of asteroid impacts. And this really helped to maintain the warm, wet climate and the thick atmosphere because of the gas that was produced as a result of the bombardment. Mars also experienced frequent volcano eruptions, and these volcanoes were massive. The largest volcano in our solar system is Olympus Mons, and it is located on Mars itself, and it is 3 times larger than Mount Everest. Just like Earth, these volcanoes on Mars were crucial and played a significant role in atmospheric recycling. Volcanoes also helped in recycling gas lost from the Martian atmosphere into the space. So when this volcanic activity ended on the red planet, the atmospheric recycling halted as well, and Mars absorbed its atmosphere sort of like a sponge. And as the core cooled, Mars's magnetosphere decreased, making Mars's upper atmosphere vulnerable to being stripped by the electrically charged solar winds. And when the atmosphere became thinner, the planet became colder. Ultimately, the temperature of Mars dropped low enough for carbon dioxide, ice to form, and draw more gas out of the atmosphere. So now, if any human were simply to live on Mars just like they would live on Earth, they would instantly die. And that would be because of the extreme temperatures on the planet. On average, negative 55 degrees Celsius. The absence of an Earth-like atmosphere composition, where even the most predominant gas is carbon dioxide, which would prove to have detrimental effects on humans. And most importantly, lack of a magnetic field, or in other words, it lacks a magnetosphere, which exposes the planet to solar winds, and it is a reason for Mars' stripped atmosphere. Now, when we consider all these things, it seems like we can never live on the planet of Mars. And that is why there are a few major steps that we have to take if we want to make Mars habitable for humans. First, we have to increase the surface temperature. Then we have to increase the atmospheric pressure. We also have to change the chemical composition of the atmosphere and make the surface wet. And we also have to reduce the high amount of ultraviolet radiation by creating a magnetic field. Now, without further ado, let's talk about how we are going to achieve these 5 things. So now there are 3 effective methods that we could potentially use if we want to terraform Mars. And luckily for us, these methods are more or less address the issue that I just mentioned. In other words, they kind of go hand in hand. The most simple and logical way to increase the temperature of the planet is to release large amounts of greenhouse gases, and that would eventually warm the surface. The greenhouse gases would also melt the CO2 ice, and that would further release even more greenhouse gases into the atmosphere. This would gradually warm up the planet to the extent that Mars' solar ice caps would melt, creating oceans. Now, from this we can understand that step 1, 2, and 3 do in fact go hand in hand, and as all of them do, specifically as all of them specifically require higher temperatures through greenhouse gases. The easiest thing to do that we are familiar with, that we are all best at doing as humans, is to set up factories on Mars. Sounds ludicrous, but it could actually work. Scientists have proposed building greenhouse gas producing factories that could generate large quantities of CFCs, methane, and carbon dioxide, which could trap solar radiation and help to build a thicker atmosphere of Mars. However, this would require a huge sum of money, especially because of the transportation process. Another thing we could do is essentially place a very large orbital mirrors around Mars to reflect sunlight onto Mars and heat up the surface. And in the end, as this is what we want, over many years, the rise in temperature would release greenhouse gases. These would probably be built in space and near Mars because they would be way too large for any means of transportation as well. So the first two have transportation problems. Many scientists believe that introducing large amounts of ammonia into the atmosphere would be enough to stimulate a global warming cycle. And this is because a lot of asteroids have ice-rich ammonia, and that can be a powerful warming devices during an impact with Mars. They also can. They have also thoughts about attaching nuclear thermal rocket engines to ammonia-heavy asteroids and directing those asteroids so that they crash into Mars and release the meteorites ammonia and water. The ammonia could raise Mars's green gas level significantly. That brings us back to nuking Mars. Could it really work? Could nuking Mars really work? The simpler answer is yes, it could, but it won't be the most effective way to terraform Mars, because it would have detrimental effects as well, such as introducing even more radioactive, making it even more radioactive than it already is, and drastically changing Mars's ecosystem. And we do not want that, because we still need to study Mars, so that we can expand our scientific knowledge and perhaps even make some major breakthroughs. Okay, so all the options presented before talked about how we could primarily increase the Mars's temperature and so that we could have a so we could live in it in a proper manner. So once we get to use any of those techniques and we increase the temperature of Mars, we would have to change the chemical composition. More importantly, we must make Mars's air breathable for humans. The most effective way to achieve this would be to introduce highly ultraviolet resistant life forms, such as lichen, directly onto the surface. And when we do that, we could also introduce them by growing cyanobacteria in the soil, which would provide the organisms the organisms from the UV. This would also help the organisms to release oxygen, which would slowly build to the breathable levels and would form an ozone in the upper atmosphere, and that would reduce the high levels of harmful UV flux. These organisms would also provide nutrients that could help build soil up to the extent that it could support even more complex plants. The last thing that we must do is to literally build a magnetic shield, and that is the only tactical solution presented so far, and it's presented to overcome problems caused by extreme solar winds. We have to make a magnetic shield if we want to be saved from the solar winds. And luckily for us, just a few months ago, NASA scientist Jim Green and his team suggested that by positioning a magnetic dipole shield with a very powerful strength of 1 to 2 Tesla at the Mars L1 point, an artificial magnetosphere could be formed, and that would surround the entire planet, ergo protecting it from solar, wind, and radiation. Green also concludes that if this magnetic shield is deployed, in just a number of years, Mars could attain as much as half of Earth's atmospheric pressure, and that is a major breakthrough. That would it would make us even more determined to go to other planets, because that is a big achievement. making a planet so close to Earth, especially its atmosphere. It's really hard to do that.
To conclude and to evaluate, to terraform Mars, we must most importantly increase the temperature of the planet. Ultimately, because when we increase the temperature, we set up this chain of events, in a sense, that have to occur afterwards. Remember the 5 steps that we have to take in order to terraform Mars? Turns out, for steps 1 to 4, we need to produce a lot of greenhouse gases. Notably, by warming the planet with greenhouse gases, we could melt the ice caps and produce water, which is the foundation for life. Especially if you look at Earth, for example, for comparison, you would understand why water is such a vital aspect of life. In my opinion, the most effective way to do this would be to send the orbital mirrors and let them orbit Mars for a long period of time. This way, we could effectively plan what we are going to do next on the planet, and while we wait, we could also be sure that once the mirrors are placed properly, they will do their job properly, especially if we consider the fact that they are meant to be durable. However, as almost with all the future endeavors, we are not 100% sure of how it will work and who will operate and regulate them. And that is my second point, to make sure that all these experiments that have been proposed become even more reliable and durable. I believe scientists should go over each proposal and officially declare what is deemed suitable scientifically and socially.
We as humans really want to colonize Mars and really want to terraform it, and we really want to achieve the goal of terraforming it. It is very possible. We have to keep in mind it is very possible. And all we have to do is put our minds into it really properly. It could be achieved much faster than anyone could imagine if we really do that. And the vital fact of the matter remains, however, that we can terraform Mars. It would just take quite a lot of effort. And by the end of the day, if you look at the bigger picture, it would be more than worth it. Thank you very much for watching, and don't forget to subscribe.